Hello everybody, Mr. Taylor here. Let's take a look at Unit 5, Lesson 12.2. We're still looking at properties of reflection, but here we want to look at explore activity number 2. Your learning objective is you use a trapezoid to investigate the properties of reflection. Again, key vocabulary: orientation, which is the arrangement of points relative to one another after a transformation has occurred. Congruence is having the same shape, size, and measure. Reflection is a transformation that flips across a line, and that line is called the line of reflection. Okay, so the author tells us that we want to use trapezoid trap, which is TRAP, to investigate these particular reflections. What I want to do is stop for a minute and talk to you about vertexes and vertices. And I know you're familiar with this, but just want to take a second. If we look at T, then we're looking at this particular point, and this point is P to T and R to T. This particular point, which is a vertex, is T to R or A to R. This particular point is R to A or P to A, and then of course the last one is A to P or T to P. These are our vertexes, and we call them our vertices. So I just wanted you to be aware of that before we go forward and have a good understanding of that. But anyway, here's what we're trying to do. Want you to trace the trapezoid on a piece of paper. Cut out your trace trapezoid, and then place your trapezoid on top of the trapezoid in the figure. Then reflect your trapezoid across the y-axis. Sketch the image of your reflection by tracing your trapezoid in this new location and label it T prime, R prime, A prime, P prime. Again, one thing you need to realize is you should be in your textbook. If not, then just go ahead and put this on a sheet of graph paper and look at the coordinates for T, R, A, and P. And if you notice, if you're going to flip it, then this is going to be your, what can I say? This will be your R prime. This will be your A prime. And going this way, let's see, what do we have? This is your P prime, and then up here is your T prime. So that's what your actual trapezoid, and then just literally connect your points. So I'm going to try to do this, even though we're probably not going to get decent lines, but some similar. So that's what we're trying to do when you do your reflection. Notice again, these 2 points go back to back. All right, let's move on. It asks us to use a ruler once you have it drawn out and measure. Especially if you got your book, you can do this really easy. Use a ruler to measure in centimeters. TR, RA, AP, and TP. Do the same thing for your, this is your pre-image. Do the same thing for your image, and then tell us what you notice, and then use a protractor. We may or may not have, but again, I keep saying, it's good to have this knowledge, but you're not going to be using a protractor on your test. I hate to say that, but anyway, let's go back. Make sure you stop it. And write the instructions of what you need to do down if you do not have your book, and just stop it and write these instructions down to answer, and then we'll come on back. So go ahead and pause it. Go back here, pause it, draw your figure, get your instructions down, okay? And then pause it here and write your instructions down for C through I, so you can be able to answer those questions, okay? And also here for E, H, and I, where you want to make an educated guess using E, H, and I about the reflection. Okay, once you do that, come on back to the video and see what we have. Okay, so as I showed you, if we trace and literally flip it over, so we're going to go like, I don't want to do that one. I want to use my pointer. So we want to go like here, here, and then here, here. So if you notice, it's going to be just like your back is to the line. This is your line of reflection, which is Y. Y is your line of reflection. So R is going to become R prime. And how do we know that during the trace? Well, this is just simply 1, 2 units from your line of reflection. A, 1, 2 units from your line of reflection. So you would take your RA and put them 2 units from your line of reflection, and automatically T and P is going to align with T prime, and P prime will align with T and P. And whereas T is, let's see, 1, 2, 3, 4. Then of course 1, 2, 3, 4 will be T prime. P is 1, 2, 3, 4, and P prime will be 1, 2, 3, and 4 units away. Okay, so I hope you were able to get that. And then again, here's this measurement thing, and you may not, but you know, just the practice of doing the measurements. Use a ruler to measure the size of the trapezoid, TRAP in centimeters. TR is 0.09 centimeters. RA 0.08 centimeters. Let's see if that makes sense. TR and RA. Well, let's see, TR and RA. So let's see which one do we see. TR is 0.9, RA is 0.8, AP is 1.2. It's a little larger. And TP is 2.1. That's the longest side. And of course TP 2.1. Okay. So then it tells us to measure T prime, R prime, A prime, P prime, T prime, P prime. And because this was just simply a reflection and we didn't do anything with the actual size itself, then these should be congruent as far as the measure. Okay, the actual length measure. So what do you notice? Again, the length of the corresponding sides are exactly the same. TR and prime, RA and prime, AP and prime, and TP and prime. Then it asks us to use a protractor to measure the angle of the trapezoid. So MT, the measure of T, angle T, the measure of angle T, 63 degrees. The measure of angle R is 117 degrees, so that's going to give us our straight line here, 180. And then the measure of angle A is 135 degrees, and then the measure of angle P is 45 degrees. So here again we have 180. So we see that if we were measuring a trapezoid, then the actual measure of a trapezoid is 180 plus 180, which is 260 degrees. But if we look at prime, guess what? They measure up exactly the same, so that means that they are congruent. And what do you notice about the measure is that the measure of the corresponding angles are the same. Okay, so which sides of the trapezoids are parallel? Well, according to the author, he says TP and RA. So let's go back and see, can we see that? Yeah. because these seem as if they're getting further and further apart, so they're not parallel. Parallels are the same distance. So these two and these two, this is 2 units, 2 units, 2 units, 2 units, 2, and if it carries on till infinity, we will still be just 2 units. So which sides of the trapezoid T prime, R prime, A prime, P prime are parallel, and we get the corresponding angles of T prime, P prime, R, and R prime, A prime. So then it says, well, what do you notice about TRAP? The sides were parallel in the pre-image, remains parallel in the actual image. Okay, so you can go ahead and stop and make sure you write this information down. And here it says use E, H, and I to make a conjecture about the reflection. So if we go and look at E, where it says the corresponding sides are the same when we looked at the length. H says the measure of the corresponding angles are the same. So not only is the length the same, the measure of the angles the same, and then the sides that were parallel are the same. So what conjecture can we make? Well, here's a sample one, what the author say, that the reflections preserve the size and the shape of the figure, but the orientation changes to a mirror image of the original. So if we go back and look at this orientation, if we notice R didn't go, when we reflect, instead of R being the very first one, it seemed like to me it became the last one here. If we look at the orientation, it didn't remain like this. If we would have just took it and slid it across, then R and A would be here, and then of course T and P. So the actual orientation of the vertices did change with the reflection. Okay, no questions? Please make sure you took good notes and understand. If not, then you can always email or commit me. This is Mr. Taylor.